My name is Dugan O'Neill. I'm the Associate Vice President Research, and I'm happy to welcome you to the Big Data Hub. This is our first presentation from the spring series of our Data Visionaries Series, and so I think we've all been waiting for the spring series to start. I'll tell you a little bit about how you can participate as we go along through today's discussion, and then a little bit about what's coming later in the term. So for today, if you want to join the conversation over Twitter, you can use hashtags SFUKey or Data Visionaries. So please participate as we go along. Today we're proud to present Chris Simpson. Chris is the chief architect of PlentyOfFish. He's worked in a variety of different industries. He's been a software developer for 20 years. The industries include advertising, business travel, and most recently, and as you'll hear about today, online dating. As the chief architect of PlentyOfFish, he's responsible not only for the day-to-day operations, but also delivering the future of the tech stack for PlentyOfFish. So Chris is supporting one of the world's largest dating apps. It has millions of members. I'm sure he'll let us know how many millions as the latest count. And this means that Chris is engaging in data every day to help people meet other people in a fast and reliable way. So on behalf of Key, it gives me great pleasure to welcome Chris Simpson, a pioneering big data leader and our very first big data visionary of the spring term. Over to you, Chris.
Thank you very much. Let me just fix myself up here. So, all right. Yeah, so my slide is entitled Learning to Fly a Kite in a Hurricane, and I hope to be able to explain what that means. I've been at PlentyOfFish for 6 months, 6 years, 4 months, 6 days, about 3 hours and some minutes. My current role is chief architect, as Doug said. I also like to call my role a technical debt collector and also a technical debt loan shark. And I hope to tell you today why that is and what I mean by that. So you imagine an architect, traditionally you're going to want a big green field, something to build a brand new castle. Build me a house here, please. That's not very realistic. Realistically, you're going to already have You're already going to have a castle. You're going to have a castle with turrets sticking out the side, with slides coming out, all sorts. And you are going to have to integrate with that. You're going to need to build something new on top of something old. It can get especially messy, especially when you're in a business that's growing very quickly. And especially in the case of startups, you need to build something, get it out quickly, and then you start building on top of that, and things cannot be generally ideal. As a side note, this is kind of my disclaimer slide for anyone who ends working at POF and says, what the hell is this I've got to work with? It wasn't me. So there's a whole bunch of challenges involved in working for a high traffic, high availability website and app now. Obviously, the big challenge that we're all talking about today is scaling. POF, you may not know, hosts its own bare metal servers in our own data centers, which nowadays might sound a bit strange. But bare metal servers are generally a lot cheaper, especially back then, and cheaper to vertically scale. And vertical scaling is a bit of a swear word, but you'll find it has been the answer to many businesses' woes. It's easier and cheaper to scale, but only for a little while. The trouble with vertical scaling is there's unexpected issues. Larger hardware can work very strangely compared to what you think. You've got this app, you get 1,000 requests per second, scale that up to 5,000 requests a second. Just adding new disk space, just adding new memory isn't actually going to solve things. You're going to see stuff that you just didn't expect. Glass ceilings are hard to see. For example, NTFS, the Windows file system, it works wonderfully for us until you hit a certain threshold. Beyond a certain number of, I think we found that more than 10,000 images in a folder. So users upload images, of course, on our site. Put more than 10,000 in a folder, it will get exponentially slower at being able to serve those images. We've seen this in a number of cases, email spooling, that kind of stuff. So it's a reoccurring theme that we see when you're trying to scale. You will hit problems you just don't expect. So the solution is to scale out. Of course, you just take your vertical scaling and you scale out. It's obviously easy. Wrong. It's not easy at all. There's a whole bunch of challenges that prevent you from being able to just turn your vertical kind of monolith into lots of little pieces. The first one is downtime. We don't really tolerate downtime. It's very expensive, and there's no good time. POF's all around the world. I wouldn't say universal quite yet. We're working on that, but it's definitely global. There is no great time to do any maintenance. We generally do a little bit of maintenance at sort of 1 o'clock in the morning at the lowest point in time, but we try and reduce downtime to 0 always. There's an interesting example in the early years from going back to the previous slide of the castle with the stuff sticking out the side. The way our website, which the site was originally back in the day before our mobile app, it was just one big website. And each of these pages would be compile on demand. What that meant was you could actually push a new page to production with some changes on it, and the first request would compile it. And for cosmetic changes, with one person changing, these things, it's fine. As soon as you try and make fundamental changes to the system, as soon as you try and change some library that changes the behavior across all the site, everything falls down. It gets terribly messy. As our team grew, we wanted to make more simultaneous changes. We wanted to, what we found was we would push changes to the site, and it would not respond. We would serve service unavailable 503s back to users, and we kind of expected a little bit of this. But the amount of time the site would not respond was disproportionate to what we expected. If you run it on your own machine, it takes a minute to start up. On the servers, it was taking 5 minutes, and what it turns out is when you've got 10,000 requests coming for a site that hasn't started yet, it actually slows down the startup time of the site. It seems kind of obvious in hindsight, but this is just one of many issues that we felt when we tried to go from a small startup, one person, small changes, to actually growing to a big team. I think the best way to describe it, I guess, is it's kind of like trying to get your key in your front door when you really need to go to the washroom. It takes significantly longer than it should because you're concentrating on something else, which is all these requests coming in. When given such high traffic, one of the interesting things I experienced when I first started 6 years ago, with all that traffic, whenever you make a small change, you push it to production, every single edge case is going to be tested in minutes. Users are sending crazy requests that you wouldn't expect at different volumes, at different angles, your page may get ripped to pieces. It's like, this is why the idea that the name I gave it is, it's like testing a brand new kite by flying it in a hurricane. It's easy, it can just get ripped to pieces. So how do you solve the downtime problem when you're taking this vertically scaled system and you're trying to grow it some more and also trying to scale out? Well, the answer's really more automation and better sort of load balancing and also taking more measurements, more telemetry. So if your site's continuously telling you how it's behaving, how the servers are behaving, you can make better choices about how fast you deliver stuff. You can deliver new changes to one server at a time. You can tell the load balancer, hey, back off, I'm going to put some changes on here, I'm going to warm it up, I'm going to put some new changes on it, which is kind of common nowadays, but it's actually quite a shift for us a long time ago. Now, having more measurements, basically listening to all that data that's coming in, which is something that we've been ramping up for years, should help you make faster decisions. That's you know more about your system, which is kind of true. But it comes with some penalties as well. So everyone knows correlation doesn't imply causation. You may have heard that 100 times. The problem is we all have cognitive biases. The more data that you have, the more things you'll see, the more ghosts you actually see in that data. I expect everyone has seen a Plenty of Fish logo in that mug. It's not really there. That's just your brain filling in for you. It's like a Rorschach ink blot test. A change to something a week ago might cause a dip in the traffic today, which might coincide with something that you actually just deployed. If you look everywhere, you'll see patterns, and the patterns aren't actually there, and then it will actually slow down your delivery just because you've got more data and more eyes on it. So you have to be careful. With great metrics comes great responsibility, I guess. So you have to find the right ones and focus on them. Use your business people and say, like, what are we actually trying to change here, and what do we definitely not want to change? A question you may have for me at the end, and I'm afraid I'm not going to be able to answer that, is what is the right metric? It's a very hard problem to solve, but the right metric isn't everything. It's just be careful. So once you have the right metrics, you got to learn to split test properly. Back in the day, we wouldn't push changes out to absolutely everybody. We'd try and push them out to half of our users at a time. Very simple split test. You take the user identifier and you mod it by 2, and odd and even basically gets the 2 versions. Does anyone know what the problem with that is? I don't know if you've covered that yet. That's sort of like a data science problem, but if you do that test, it'll work okay. It'll tell you, you may get a disproportionate load of users depending on how you actually give these user IDs out, but it should be fine. But then you do another test. and you split it the same way. You end up with the same users always in your test group versus your same in your control group, and that creates a bias. Just don't do that. It's pretty easy nowadays to basically take a number that you want to split on, combine it with some sort of hash, some sort of salt or whatever, and then split on that, then mod on that. So that's something that we learned the hard way. Other challenges is not just high amount of traffic and a lot of data coming in, is that we have to make changes very frequently. A high-paced environment is one where we just have to keep delivering new changes. And it's not just because the market was shifting. POF has grown and been quite successful, I think, because it's responded to changes in the market pretty well, and managed to stay on top, stay afloat. But there's another fundamental reason why we have to make changes quite frequently. And I don't know if anyone wants to take a guess on what our most important thing that we do at POF is. That's right. It's fraud and scam detection. It's very important to match the right people to the right people, to enable them to message each other. But being a free service, it's very easy for someone to come in and disrupt that, either just by being a jerk or actually trying to make money from our users. So we work really hard to stop that. But we have to continuously play cat and mouse with new fraud scam ideas. So we have to keep making changes. We have to keep pushing stuff to production. So this is a blocker to us basically doing a major shift to our architecture. So the reason for this picture here, when you're making technical decisions, when you're trying to take a vertically scaled site and you're trying to break it down and make it into something that's horizontally scaled, you have to make lots of technical decisions. You're also making technical decisions for every small product change that you're making along the way. And you have to decide how quickly you want these. And so there's this little chart. On the left, we have a cowboy coder, basically. They have they can get to production really, really fast, but they will increase coupling and they may lower cohesion in your code. And I'll explain what coupling and cohesion are in a little while. And on the right, we have an architect astronaut. And the architect astronaut is planning for what we might need in 5 years' time. And by doing that, increases complexity while not actually helping deliver what you need today. So you have to find a sweet spot. And for me, the distance between that sweet spot, which is actually quite difficult to locate, and what you actually deliver can be measured in technical debt. So technical debt is the distance between what you really should have delivered to what you actually did. And that's how much you're going to have to recover later. So startups will incur technical debt because they need to get to production fast. And it's okay, technical debt's an investment. First to market will always be architectural purity. But technical debt's kind of like a loan. You have to pay it back. It's in fact not a loan, it's more like a credit card bill. For the life of that particular feature, you basically owe money on your technical debt credit card. And you'll be paying interest payments from that day onwards until you pay that back. Like I said before, as sites grow rapidly, they will make not the best decisions for 5 years, they'll make the best decisions for now. So you can start incurring quite a lot of technical debt. And with a high-paced site, it's quite likely you're going to miss a few payments on your technical debt. So eventually, you're going to need an architectural revolution, especially if you're trying to take a large site service that's vertically scaled and scale it out. You need some fundamental changes in ideas to lower your coupling and raise your cohesion. So coupling and cohesion. Imagine if you deployed a module to production to fix messaging, but it actually broke payments. That means you've got a coupling problem. That means that a change to one part of your system can affect another. And the cohesion side of things is if you want to go and make a change to messaging, how many things do you have to touch? How many people do you have to talk to? How much change do you actually have to make to do that? You want to lower your cohesion. You want the minimum amount of changes required to get your feature change in place. So that's what we're trying to do. So we're also trying to reduce our monoliths. So you have these very large servers serving a heck of a lot of requests for a lot of different reasons. And we want to have a larger number of smaller servers doing very specific things. But I just want to make it clear that we wouldn't be here, I wouldn't be talking to you if we hadn't built monoliths, if we hadn't grown this technical debt. I'm allowed to hate the technical debt now and try and pay it back. So there's a local DDD evangelist. His name's Robert Reppel. I don't know if anyone's been out on the local kind of meetup circuit. You may have met him, but to describe coupling, cohesion, he uses car analogies. And one really great one is that your car radio, you don't have a button on your car radio that controls the locking system in the car. The two systems are not connected at all. It might sound like an interesting idea, but you wouldn't want your radio broken, meaning you're locked out your car anymore. It sounds obvious, it's daft, but in software we see it all the time. The two systems are linked, and they really shouldn't be. By separating the two, by having a separate locking system to the radio, it means you can use that radio in different cars. It means you can replace the locking system and you don't affect the other. Monolithic databases are just as bad as monolithic services. So you put all your data in one big database, it serves 20 different purposes. As a veteran software developer, I was raised and I learned in the era of normalization. Normalization is where you take data structures and you break them down. So you store the same piece of information once, as infrequently as possible, and you create this structure of related tables in your relational store, and you put the appropriate columns in them so that you can serve many different purposes from that same piece of data. It's kind of a crazy idea nowadays. You don't see that, especially for a high-scaled website. You can store, like, the disk space is cheap today. Syncing isn't actually such a problem as it may once have been with the right tools. You should move on. Excuse me. So yeah, nowadays we see that storing one piece of information in a way that serves many purposes doesn't really help us. It slows things down. Access to that data is a premium, and you have to convert that data into the form that you want to present to the user. Why not store it in the way that it's going to be presented to the user in many different forms? So that's what we're working towards. We're trying to go from a very kind of data-centric model to these asymmetric read models. What that means is we're going to store data in separate places to serve particular purposes instead of try and have a large relational data store. Which might sound fine to you. I mean, you may have seen, the university learning about sort of computer science and big data, and that might just sound really normal. But to anybody who's basically been building databases for 20 years, it's quite a paradigm shift. It turns everything upside down. It's very hard to get out of those old habits. So, I don't know if anyone's heard the acronym Keep It Simple, Stupid. It's one of my favorites. It's actually it's withstood the test of time. When you're making architectural decisions or just regular software development sort of decisions, it's the best thing. Make your work as complicated as it needs to be and never more complicated. And the reduction of coupling and the increase in cohesion that comes from separating your services out, all part of the scaling out, actually gives us that. It makes, I had a wonderful conversation with a colleague only a couple of weeks ago saying, how are we going to build this? And now we have this new plan. Now we have a new way of building things. It was very easy. We just said, okay, well, you need a database that looks like this because that's what the data needs to look like. And you're going to need a service to present that data to the user. You don't need to bother that team or that team. You can build this entire stripe yourself. So it's starting to work now. You also, obviously, like I said, you need the right metrics. You need to. You're gonna. I can't stress this bit enough. You're going to affect the other systems by making changes. You'll have unexpected changes to other parts of your system. And if you have too many people watching too many numbers, you will never be able to move forward. So we're now very careful, and we've learned this over the last few years of this architectural kind of shift, that focusing on what the business cares about. We want more people sending good quality messages. We want more good quality users signing up with the system. Very broad metrics. And if my change does that, it doesn't matter that the latency increased by 20 seconds over here. It doesn't matter necessarily that CPU's gone up 10% on that server. So just be careful what you look at. Keep keep your business metrics separate from your telemetry, your operational metrics. And finally, so a journey to a nice horizontal scaled architecture is useless without decent automation. We've used automation as much as possible over the years, but we've done a fair share of manual deployments as well. As soon as you scale out, you're going to find that prohibitive. It's not possible to update 100 machines with the same configuration. It just doesn't work. So get your automation right too. So what's the future? Oh, look, I got a mouse. The future of Plenty of Fish. So we started on this journey to go from a vertical scaled system with lots of monoliths into a horizontal scaled architecture with separate read models and separate services. And we're going to carry on that. It started to show some benefit already. But like I said about automation, we do a pretty good job right now. But when you're talking about hundreds of servers instead of tens of servers, you really need somebody else to start managing what service lives where and how. And so we're going to start talking about technologies like Kubernetes soon and introducing kind of an automated elasticity into what we do. And the other thing is, and you may not know this, so the Plenty of Fish office is downtown in the Harbour Centre. We're approaching 100 people there, but we don't have employees anywhere else. We also don't have any data centers anywhere else. We have except for disaster recovery and backup, offsite backup. All of your requests go through the Harbour Centre, which is great if you're in SFU and you're searching and swiping. Not so great if you're in Europe or Australia, for example. So the opportunities for scaling out mean that we may be able to start spreading around the world and effectively fix that latency problem that you get from a 200 millisecond ping time from Australia to here. Although I'll put a question mark. We haven't confirmed this yet. But yes, at some point I want to move some of our data to other data centers, just so I get a trip around Europe. But that's about it. I hope I've kind of tried to explain what I mean by flying a kite in a hurricane and kind of what the choices you have to make with technical debt. I tried to explain kind of that technical debt isn't necessarily a big problem up front. It can actually be a business winner, but you will eventually have to pay for it, and that's what my job is. But thank you very much for coming to talk to me.